Hello guys, in today's class we will discuss the topic that is decision tree learning. Okay, so it is very important type of machine learning model for classification model, that is a classification model of supervised learning. Supervised learning. Okay, so decision tree learning, a hierarchical data structure that represent data by implementing a divide and conquer strategy. Okay, it is implemented by divide and conquer strategy. Decision tree are classifier, for instance, represented at feature better. Okay, it is represented at feature better. So for you see here example, here the color are different color are first color is red, blue, green, and shape different shape are there. So circle, triangle, and rectangular, and different level are there. First level is A, B, C. Okay, so an example, if color equal to green, if color equal to green and shape equal to rectangular, you notice here color equal to green, okay, and shape equal to rectangle, okay, shape equal to rectangle, then it is called as B level. Here you notice in diagram, okay, color is green and shape is rectangular. So it is called as label B. So here we classify like this. Okay. So here you notice first we take the color, then a different shape are there. Suppose the color is red. If color is red, then it is called as B. You notice here in B there is only red color is present. Red color does not present in A and C. So here you conclude that color if red then it is B. Okay. Then if color is green, here you notice the color is green. Okay. If color is green then you notice it may be B, it may be A. Okay. If color is green then you come to shape. Okay. If you notice shape is rectangle then it is B. If shape is circle, then it is A. Okay, here you notice in the diagram. Okay, so if you color is blue, you notice if color is blue, then you notice if it is circle, then it is C. If it is circle, then it is C. Okay, if it is rectangle, then it is A. Okay, if it is triangle, then it is B. You notice in the diagram. So we classify like this in decision tree algorithm. Okay, so the goal of is to have the resulting decision tree as small as possible. The main decision in the algorithm is the selection of the next attribute to condition. To notice the condition. Okay, so here suppose I give you example like this. Suppose your age is 40. Okay, 14. And if age, okay, less than 15, okay, if age less than 15, okay, print school, print school. Else if age greater than 15 and age less than 21, then print college. Okay, else age greater than 21, okay, it will print working person as a working. Okay. If we draw the decision tree of this algorithm, okay, like this. First, you will notice age, okay, less than 50. If it is true, okay, if it is false. So if it is false, okay, if age less than 15, okay, the- if age less than 15, that is yes, then you directly go to the school. If you know, then you check the second condition. Second condition is age greater than 15 and age less than 21. Okay. If second condition is true, okay, or yes, then directly you go to the college. Okay. If second condition is false, then you directly go to the working. Okay, it is the example of disjunctive. So here you notice disjunctive boundaries. So usually instances are represented as attribute value pair, that is color equal to blue and shape square plus. So numerical value can be used to either by decreasing or by using threshold for splitting node. Here you notice here some plus 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 minus minus plus minus present. Okay, here you conclude that when x less than 3, when x less than 3, okay, so if x less than 3, then you notice what is the value of y. If x less than 3 and y greater than 7, y greater than 7, then it is plus. If y less than 7, then it is minus. You notice here. If x greater than 3, if it is y greater than 7, then it is plus. If y less than 7, then it is minus. Okay. So, um, here you notice, okay, like this part complete. If y less than 5, if y less than 5, then you notice it is plus. Okay. It is plus. And if x greater than 1, then it is maybe plus. For this it is plus, for this it is minus. Okay, so directly we will discuss a disjunctive algorithm, that is most important algorithm, that is also called as ID3 algorithm. Okay, so suppose a example is there, suppose some features is there such as outlook, temperature, humidity and wind. Okay, suppose outlook is what is the weather, that is maybe sun, maybe overcast, maybe rain. These are the features and these are the value of features. Okay. If temperature may be hot, mild or cool. Humidity may be high, normal, low. So wind, strong or weak. Okay. These are the features and these are the value. So here you decide we will play tennis or not. Okay. If features are like this, then we decide we will play tennis or not. Okay, so label is there binary classification, that is plus or minus, or will play or not play. Okay, suppose you look this sunny, you can decide if outlook is sunny, okay, then overcast, then rainy. If outlook is overcast, then we directly conclude that we will play cricket. Okay. If outlook is sunny, then we check humidity. If humidity is high, then we cannot play. If humidity is normal, then we play. Okay. If the outlook is rain, then we check also wind. If wind is weak, then we play. If wind is strong, then we cannot play. So it is the decision tree for this feature. Okay. So For decision T, we will calculate two method. That is, first one is by entropy or by Gini index. Okay, so first we will see entropy. So entropy of a set of example is related to the binary classification. Okay, it is related for binary classification. So for binary classification, the formula is entropy of S equal to minus P plus. Okay, so true probability into log of P plus minus P minus log of P minus. We'll see in example. Okay, we'll derive a decision. So here P plus is the proportion of positive example in S and P minus is the proportion of negative example in S. So if all the example belong to the same category, that is 1, 0 or 0, 1, then you remember entropy is always 0. If all the example belong to the same category, we will conclude that entropy is 0. If all the example are equally mixed, that is 50% and 50%, then entropy is always 1. Okay, you remember maybe your short question will appear like this. If all the example are equally mixed, then what is the entropy? You will directly write the answer 1. If all the example belong to the same category, then entropy equal to 0. So entropy means level of uncertainty. Okay, in general, where Pi is the fraction of example level, like if it is multi-class classification, then entropy formula is like this: minus summation I equal to 1 to k, that is Pi of log of Pi. So entropy can be viewed as the number of bits required on average to encode the class of level. If the probability for each 0.5, a single bit is required, for example. If it is 0.8, can use less than 1 bit. Okay, so here we'll notice this is the our data set. Here outlook is present. O means that is outlook, and T means that is temperature, and H means that is humidity, then double means wind. And we decide we will play or not. Plus means we will play, minus means we will not play. Okay, here outlook has three value, that is sunny, okay, and overcast and rainy. Okay, so here in temperature there is two feature, that is hot, medium and cool. Okay, in humidity there is three value, that is high and normal and low. Okay, so low is not present. Okay, and in wind you will notice S means strong, double means weak. Okay, so we'll directly solve an example how to draw Gini index, sorry, how to draw density by using entropy. Okay, so here you notice calculate the current entropy. Okay, so if you calculate the current entropy, that is, if you notice for current entropy, will play or not. If you notice here, the probability of plus means probability of positive, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So here total is 14. Okay, so here you conclude that 9 by 14. Okay, if you go to P minus, that is for negative, you count 1, 2, 3, 4, 5. So 5 by 14. Okay, so the formula of entropy is minus P plus log 2 P plus minus P minus log 2 P minus. Okay, so here we will calculate like this, that is minus 9 by 14 log 2 9 by 14 minus 5 by 14, okay, into log 2 5 by 40. So the answer will be, if you calculate, the answer will be 0.94. Okay, so like this you will calculate entropy of every feature. Okay, so here we calculate the overall entropy, that is for play. Okay, so now here we will calculate the information gain for every, okay, independent feature. Okay, so we'll first calculate the entropy of play, okay, that is dependent feature, and then we calculate the entropy of independent feature. So first one is humidity. Okay, so information gain, how to calculate information gain, that is entropy of overall minus summation of V belongs to values, that is SP by S cardinality, entropy of S of V. Okay, if you calculate, so here you notice for entropy calculation, if outlook is sunny, if outlook is sunny, then you notice here for calculation of entropy, mm, outlook is sunny. Okay, so how many sunny is present? That is 1, 2, 3, 4, and 5. So positive sunny, that is here one positive, here one positive. Sorry. Mm, if you notice for sunny, that is here one sunny, here and here. So total is 5. Here you notice the positive sun is 1 and 2. So 2 by 5. Okay. If you notice for minus, that is next 3 by 5. Obviously. Okay. So here if you calculate the entropy when outlook is sunny. Okay. So if you calculate by this formula, that is minus P plus log 2 people plus minus P minus log 2 P minus. Okay, so the formula is minus 2 by 5 log to 2 by 5 minus 3 by 5 log to 3 by 5. Okay, so the answer will be 0.971. Okay, if you calculate similarly, if entropy, okay, entropy outlook will be overcast. Okay, outlook will be overcast. So the entropy will be 0 because you notice here P positive equal to 4 by 5. Okay, overcast, you notice here overcast, that is positive, that is also positive, and that is also positive, that is also positive. So if all are in same category, then entropy will be 0. Okay, similarly, if you calculate entropy of, okay, overcast equal to R, okay, that is rainy, so the entropy will be 0.97. Okay, after that you will calculate the information gain. Okay, so you know the formula of information gain, that is entropy of S, entropy of overall. Okay, so entropy of overall is, we will calculate it in, sorry, ठीक है. So here we will calculate it for outlook. Okay. So for entropy of overall is 0.94. Okay. So here, according to formula, gain equal to for S outflow is 0.94, that is entropy of S, entropy of overall, and summation. Here you notice how many present. So if you notice 5 by 14. Here for fast, that is 5 is present. Okay, for sunny. Okay, so 5 by 14. Total is 14. Here sun is 5. And entropy of sunny. Similarly, minus 4 by 14 into entropy of overcast. Okay. Similarly, minus, that is last one. Last one is 5 is present. So 5 by 14 into entropy of raining. Okay. So if you calculate, so 0.94 minus 0.694. Okay. And it is the 0. So 0. It will be 0.246. Okay. So 0.246 is for outlook. Similarly, we will calculate for next one is temperature for humidity. Suppose we will calculate the inversion get of humidity. So you calculate like this. Here you notice, suppose humidity is high. Humidity is high. If humidity is high, then you notice here probability of positive, that is 3 by 7, and probability of negative is 4 by 7. Okay. In high, total is 7, 4, 5, 6, 7. And for plus, that is positive is 1, 2, and 3, and okay. So 3 by 7. Okay. And next is negative. So 4 by 7. Okay. If you calculate the entropy using the entropy formula, okay. So for this, the entropy will be 0.985. Like this, when humidity is normal, the entropy will be 0.59. Okay, you calculated, you notice here in normal, okay, there are 7 features dependent. So P positive equal to minus 6 by 7, and P negative equal to, that is next 1 by 7. Okay, so here you will calculate information gain. Information gain. So S of overall, that is we will find, that is 0.940 minus the probability, that is 7 by 14 into 0.985, that is entropy of high. Okay, minus, that is 7 by 14 into 0.592. So the answer will be 0.246 if you calculate. Okay, so like similarly, we will calculate the information gain for, okay, for wind. If you calculate the information gain of wind, that is 0.048. You calculate accordingly. Okay. If you have any doubt, then you ask in comment or in Telegram group or in WhatsApp. Okay. So next is temperature. If you calculate the temperature information gain, then it will be 0.029. Okay, so okay, so here we will write. So information gain of outlook is 0.246, information gain of humidity is 0.151, and information gain of wind is 0.048, and for temperature that is 0.029. Now we will look which have highest information gain. Here you notice which have highest information gain, that is 0.246. So which have highest information gain will split will split first. Okay, so here information gain of outlook is highest, so we'll split first outlook. Okay, so here you notice information gain of outlook is highest, so split first outlook. So according to diagram, for outlook, the split is sunny, it may be overcast, and may be rainy. If you notice in overcast, okay, when overcast, okay, here and here and here and here, the output is play, that is positive. Okay, so we directly conclude that it is play, that is S. Okay, and for sunny, that is 2 positive and 3 negative. If you notice for sunny, total sunny present is 5, and here 2 are positive and 3 are negative. So we cannot conclude. So here we will also calculate the information gain. Okay, then we will split. Okay, like this rainy. In rainy, that is 3 positive and 2 negative. So accordingly, every attribute is included in path or all example in the leaf have same level. Okay, so after that, if you calculate S is sunny or humidity, okay, sunny and humidity, then the information gain will be 0.97. If you calculate sunny and temperature, okay, if you take temperature, okay, then it is 0.57. If you take sunny and windy, then it will be 0.2. So here we will split humidity, okay, because humidity has highest information. You calculate accordingly. It is a big process in calculation. Okay, so we'll split humidity. If humidity is high, then it will not play. If humidity is normal, it is play. So we directly conclude. Now we see the features running. Okay, if you calculate like this, so in features any, that is, if wind is strong, we will not play. If wind is weak, then we will play. Okay, so hypothesis space in distance induction. Okay, so conduct a search of the space of distance which can represent all possible discrete function, that is for pros and cons. Okay, so goal is to find the best distance. So best could be smallest path. Okay, so we'll calculate the smallest path. So best could be the minimizing the expected number of tests. Okay, so finding a minimal distance constricting with a test of data, that is NP hard. Okay, it is a NP hard. Perform Gary heuristic search, that is hill climbing without backtracking. So you will read hill climbing in AI. Okay, so make statistically based distance using all data. Okay, so here is Gini input. Okay, we'll see the distance in using entropy. Okay, Now we'll see how to do descent using Gini impurity. The process is 100% same. Only difference is the apply a formula for reduce some calculation. Okay. So Gini impurity is measure of impurity or disorder within a set of data. Okay, it is commonly used in descent algorithm such as CART. CART means classification and regression. So to evaluate the quantity of the split in dataset during tree building process. Okay, so here we will see what is the formula of Gini input. Okay, so first you know that is the formula of Gini impurity like this. So 1 minus summation of I equal to 1 to n pi whole square. Okay, so you will calculate first Gini impurity. Okay, like this. Suppose your 1 minus p of positive rho square minus p of negative rho square. Like this. We will calculate Gini. Okay, so we will directly see with a example that is suppose mm, okay, so Gini impurity formula is 1 minus summation I equal to 1 to n pi whole square. Suppose if present p of plus equal to will calculate in entropy. So like this, if p of plus equal to 3 by 6 and p of minus equal to 3 by 6. So how we will calculate? That is 1 minus that is 3 by 6 whole square. So plus 3 by 6 whole square. That will be 1 minus 1 by 4 plus 1 by 4. That is 1 minus 1 by 2. That is 0 0.5. Okay. So it is impure split. If you calculate the Gini entropy, if sum p plus is 3 by 3 and p minus is 0 by 3. Okay, how will calculate for this? So if you calculate 1 minus that is 3 by t 1 square plus 0 square. It is also called 0. That is pure split. Okay. So here if you calculate the information gain using Gini entropy, Gini impurity or Gini index, so how will calculate? So gain of S of f equal to h of s minus summation, that is v belongs to value s of v by s cardinality into h of s. It is similar to entropy. Okay, first we calculate the overall Gini index, then we calculate the some part in some value of features Gini index, then we will calculate the overall gain of that feature. Overall gain of that feature. Then which of the highest which of the highest information gain will split that feature. Simple. Okay, so Here, if you calculate the information gain in last example, okay, so you calculate like this overall, suppose overall is 0.94 on suppose it is 8 by 14 that is 0.81 that is the information gain of first plus 6 by 14 that is information gain of second that is 1. Okay, if you calculate like this 0.049. Okay, so higher information gain will split that. Okay, if our information gain is highest, okay, if information gain is highest, then we will split that feature. Okay, so here if you show the graph of entropy and Gini index, so graph will be like this. Okay, it is the graph of entropy. Okay, and it is the graph of Gini index. So in entropy, okay, in entropy the limit is it is 1. Okay, so in entropy the value will be 0 to 1. But in Gini index the value will be 0 to 0.5. That is 0.5. Okay, so here, so you have doubt where we will apply the Gini impurity, that is Gini index, and where we will apply the entropy. It depends upon you. But generally, when, so where we will write, okay, so next slide, where data set is small, data set is small, then we generally apply the entropy. Okay, when data set is large, for minimizing the calculation, we'll apply the Gini impurity. Because in Gini impurity, logarithm function is not used. Okay, so the calculation will be minimized. Okay, now we'll discuss decision tree, postponing and preponing. Okay, first we will discuss the postponing. Okay, so postponing involves going the decision tree to its maximum depth until a stopping creation is met. Okay, so it will split until the stopping condition is met, and then pruning back the tree by removing nodes that don't significantly improve the model's performance on a validation set. Suppose you will show a example. Suppose it is your example like this. Some label are there. Okay, so after this level, the data will be split like, okay, suppose here is present, that is 9s and 2 no. Okay, so here is present 9s and 2 no. So here it will be stop because the s will be more, so it will no go to the next depth of discernity. So it will conclude it probability come S. Okay. So 9S3 no. So after this level, all the level shows output S because maximum is S. Okay, it is suitable for small data and it is suitable for small data. So here you will notice cost complexity tuning, that is using a cost complexity parameter, example alpha, to measure the trade-off between, okay, measure the trade-off between complexity of the tree and its fit to the training data. Pruning nodes with higher cost complexity value can lead to a simple here. Okay, so reduce error pruning. Reduce error pruning. Okay, that is REP. For removing a node that don't improve the accuracy of the tree on a validation set. Okay, so remove that node like this in example. Okay, so now we'll discuss pre-pruning. Okay, so in pre-pruning, suppose a data set pre-pruning first we show the definition involves stopping the growth of this entity before it becomes too complex or fits the training data too closely. This is done by the setting stopping criteria during the tree building. That is, suppose your data set is there on for some suitable parameter, okay, and hyperparameter Turing. So in suitable parameter that is present max, depth, and split on criteria. Okay. So hyperparameter Turing is select best parameter. Select best parameter. Okay. So accuracy is hyperparameter Turing. Suppose here maximum depth is, you notice maximum depth is 3. So in pre-pruning maximum depth, that is limited the maximum depth of the tree. Okay, once a node reaches this step, it is not split further. Once the node become, okay, it will not split. Okay, so minimum samples per leaf, specifying a minimum number of samples required to create a leaf node. If you split your result in fewer sample than this threshold, it is not allowed. Okay, suppose minimum sample set split requiring a minimum number of sample to perform a split at a node. If the number of sample is below this threshold, then it will be not split. That is also minimum sample split. It will depend upon the threshold. Okay. And maximum number of leaf node. Third one is, it is the first one. It is the second one. Third one is maximum number of leaf node. Okay, so limiting the leaf node in a tree, impurity threshold, stopping the split process when the impurity, suppose the gene impurity that is falls below a criteria threshold. Okay, here the split will become stop. It is called a pre-pruning. Okay, now, so in today's class, we will discuss here first one the decision tree, how to draw decision tree using Gini index and entropy. Then we'll also discuss postponing and preponing. Okay. So in next class, we'll discuss most important topic that is your cross validation. Okay. So we'll stop here. Thank you.